All right, so updates with our technology. So first thing, homework 7, which is on material we haven't covered in class yet, but you've read on, chapter 7. The homework 7 assignment, the very last question where you're supposed to upload your R, was accidentally sent as an essay question instead of an upload question. I changed it, but since people have already started it, you can't see the changes. So on homework 7, email me your R code, your knitted R to your PDF. Just email it to me because I can't change it on the assignment. I realize all the frustration with the assignments. The other thing is I changed the deadline for homework 7 to the 12th on Wednesday. But if you started it before I made that change, it'll automatically submit it tonight at midnight. So, technology, we love technology.
You can save the page as a PDF file, and then you have all your answers.
Well, I can set it so that you can view your answers after you submit it, and that you have an extra attempt so you can open it, but you'll have to go put your answers in all over again. So let's see if we can get through it all today in class, and then solution, right? And then, so my goal is for us to get all the way through chapter 7 today in class. And then we're supposed to be doing chapter 8, power and effect size. That is a smaller chapter. So I'm going to push that till Wednesday, and we should be able to get through that and correlation most of the way. Then next week on Monday, it's President's Day, so we get a day off. And then Wednesday of next week, we'll finish the correlation and do the regression. So I have already gone in and I have changed. So the way the assignments are set up in Canvas, I am not happy with. The thing where they're 100 questions long and you're scrolling forever, I'm just not happy with how it functions. So I went into chapters 9, 10, 8, 9, and 10, or just 9 and 10? Let me check. And I was working on changing them up. Yeah, so 8, I condensed it a little bit. So there's only chapter 8 is only 8 questions on the homework assignment. I mean, this is the whole homework assignment. There is no R part. It's very short. But chapter 8 is using G-Power. So I just barely, few minutes ago, sent out another Canvas announcement that has a link to this web page for you to get a little piece of computer program called G-Power. And it's a Dutch site, but it's safe. So you go there. You have to scroll down a little bit. It has some screenshots, registration, help, references, feedback, and then you get to the download. So just make sure you scroll down, and there's a link for Windows, and there's a link for Mac. Windows, when you click this, it'll download a zip folder. It says you have to unzip it, but on Windows 10 you don't. You just double-click on that folder and then click on Setup, and it will install it. Mac, when you double-click on this, it will download it, and you go through the regular process of installation that you do with regular software. So you'll need that for Wednesday, the next time we meet together, okay? So chapter 8 is quite short compared to 5 and 6 and 7. And so there's only the 8 questions on the homework. Almost every question on the homework uses G-Power instead of all those formulas in the book, because that's what we do in real life. You know, let's not make this harder than we need to. I just did a workshop today on using G-Power to faculty and grad students. It's a great thing. Everyone uses it. Yes?
Can you recall that workshop? Because the time you have workshop, you have that meeting.
Yeah, no, and I didn't get it recorded today. We had problems with the computer. Lovely computer. So it didn't get recorded today. Sorry. But you're going to get it on Wednesday.
Okay, cool.
Right? Wednesday we'll do G-Power for t-tests. And then as we go through ANOVA, we'll go back to G-Power and how to do G-Power for ANOVAs, all the different kind of ANOVAs we're going to do. So you'll get your first, so what I did in the workshop today, you'll get the first half on Wednesday, and the rest of it you'll get throughout the rest of this class. So even though you missed the workshop, you'll still get it because you're here. So yeah, so G-Power is a software that you can use to estimate the sample size you need based on a bunch of information, including what test you're going to run and what effect size you're going to need or want to detect. And so we'll talk about on Wednesday what is effect size and how do you run a power analysis and do it in G-power. So that's the nice thing. Chapter 8 is coming up. 8 and 9 are short. 8 is really short. 9 is somewhat short. 10 is pretty short too. So 5, 6, 7, 8 are heavy, and then, or 8, 9, 10 are lighter. Which brings me to, so the assignments, I don't like how they've been set up on Canvas. Jeremy did a great job, but it's just not user-friendly. So what I did is I went and I copied the worksheets that I used to use. You do not need to do anything with this unless you want to. Okay, so these are the worksheets I used to use. This is, chapters 5 and 6, which we've already turned in, and 7 and 8. These are the same problems that are in Canvas. We just copied and pasted the text into Canvas, which are copied and pasted out of the textbook. If you want to work the questions by hand on the paper, and then you can just enter the answers into Canvas, this might, if you're a pencil paper kind of person, because I am, because I'm old, then this might be beneficial to you. If this is not your thing, then you just, just quietly recycle it. Okay? The colors, yeah, I'm a color person. I was a high school teacher before I got my master's degree, so that's my high school teacher coming out. Okay, so I think I sent you an announcement last week when I was doing this. If you go, here's on Canvas. I'm going to go to the Stat Foundation link. So this goes to our class website. So here are all the links. I cleaned it up a little bit. So here's our table of chapters. So I made a new column with worksheets. And what I did is I took the PDFs. I had them put together by unit, which we're not following that same. We had 5 units. We're doing 4 tests, so I kind of rearranged it. But here, I chopped it up. So this link is for the PDF of just the chapter 6 pages out of that thing. And here's just the chapter 7 pages out that I gave you. And here's just the 2 pages that are chapter 8 out of that thing. So if you wanted to print, I was going to let you print them off, and today I was like, I owe it to you, so I printed those off for you today instead. So, and I'll get you the next set, which is chapters, what? Where does that leave off? That leaves off on 8, so 9, 10, 11, 12. I'll get that one for you. If you think it's helpful. If you think it's not helpful, then I guess I don't need to worry about it. But I want to help you out. So that, I think it gives you a little structure to write things down, to visually organize the information. But they're here. Yes?
Just for clarification. So that homework column under worksheets is this exact thing. So it's the same thing for 1, 2, 3, 4, and
1, 2, 3, 4 was unit 1, and I haven't given them to you. I've given you 5, 6, 7, 8. Huh?
Are they printable on there?
Yeah, so if you click here, the chapter 8, it takes you, it's a PDF, and you can print it. It's just the last 2 pages of that packet, because that packet has chapters 5, 6, 7, and 8. The links here, I chopped it up, so it's 1 chapter at a time. And you can ignore that front page. That's how we used to score it. So chapter 7, if you click on the word HW7 here, it'll be more pages. Come on. There we go. So it's, in that packet, it's page 19 through 28. Oh, I didn't chop off chapter 8. So it should go to 25. So I gave you too many pages. All right, so this is what we're going to go over today in class, is 2 independent samples, looking at the mean difference between 2 samples that are independent, not matched pairs. We're going to do matched pairs like pre-post test, husband-wives, parent-child, dark, light. We're going to do matched pairs later. Here it's just independent groups. So see how I have everything like organized? This is in high school teacher language, we call this an advanced organizer for all your information. Color-coded, craziness, yeah. So we're going to go over, instead of doing a big PowerPoint slideshow, me lecturing, I want to go over this, homework questions. And with that, our encyclopedia has all of how to do it in R. So in this encyclopedia, it's in the ANOVA volume. It's chapter 4 here, independent samples, t-test for the differences in means. So we're going to go over, this is how to do it in R, and we're going to do the homework how to do it by hand too. Does that sound like a good plan for today? All right. The whole thing is 2 groups, and we want to know if they are the same or different. Okay, if I go back to, here I'm going to, 7. I'm going to get this formula sheet up here too. This formula sheet, you'll want to have that handy when you take the test. Print it out. Lookup tables in the book. So far we've used Z table and T table. I'm going to try to make it so you don't have to use the tables on the test, because that's just a lot of paper I have to make available somehow electronically. You will never have to memorize them though, so that's the good stuff. Okay, formula sheet. Okay, so we're going to come down here to the bottom of this first page. So it says 2 independent samples not paired. So that we call them, in this sheet, we're just going to call them sample 1 and sample 2. Group 1, group 2, population 1 and 2. That can be boys and girls, it can be treatment control, whatever. We're 1 and 2, just 1 and 2. So all of these little subscript numbers are 1 and 2 referring to the groups. So if we're going to do, when we have 2 groups and we're comparing them, we compare them by the difference. How do you get the difference? What math do we do? Subtraction. Now, is that the only way to compare 2 numbers? What's another way to compare 2 numbers? A ratio. Well, we're going to compare them with the difference. Ratio is a different thing. So what does this formula right here tell us? We have x bar 1. What's that? The first sample's average. What's x bar 2? Second sample's average. And we subtract them, and that makes capital D. Capital D bar stands for the difference between the 2 samples average. D for difference. We're using a capital D. Here. So the difference in 2 samples means is this capital D. That's difference. And that's going to be what we're going to see. Are the 2 samples ever going to be identical averages? Probably not. They're probably going to be averages that are different by at least a little bit. And we need to know, is it just a little bit or is it a little bit? Big bit. And the way we do that is with a t-score and the standard error. Now, look at the subscript. What's the subscript on this standard error? Capital D bar. So this is the standard error, not for one sample, not the other sample, but for the difference between the 2 samples. And there are 2 different ways you can get the standard error for the difference. This first one is called the separate variance test, and the second one is the pooled variance test. Do not look at the slideshow, the PowerPoint, because it gets it wrong. It gets it confused. This is right. This is right. Gone over this lots because they're easy to get confused. The separate variance test is what we use if we have equal sample sizes. If our n's, our sample size in our 2 groups, are the same, or if we violate homogeny of variance. You guys read about homogeny of variance? What does homogeny of variance say?
Both variances should be similar.
Yeah, the spreads in your 2 groups are not equal, but very similar. The eyeball rule of thumb is if you look at the variances, one variance can't be more than double the other. So if one has a variance of 2, the other one can have a variance of 4, and then they're still homogeneous. If this variance was 5, that would be, what's the opposite of homogeny of variance? Heterogeneity of variance. These words are fun. Heterogeneity of variance. Ugh. All right. So if we're going to assume so we can either assume that the variances are not equal because we violate homogeny of variance, or we can assume that the populations have equal standard deviations. If the standard deviations are 2 and 3, are they exactly the same? No, but they're they're roughly the same. So we could use the pooled variance t-test. If the variances are like, and standard deviations are like 5 and 1, we probably ought to use the separate variance test. Yeah?
So can you use, like say you have a male and female,
Uh-huh.
right? Can you, do you have to always use the, like, can you ever use them as homogeneous, even though they're completely separate?
We're looking at the variance in the score that we're measuring. So it's not if men and women are the same as each other. If we're doing a t-test on their IQ, we want to know, is the spread of IQs in the women about the same as the spread of IQ score in the men? It's the spread of the thing that we're measuring, not comparing the groups to each other. Like, men and women are not the same. It's a fact. It's a biological fact. And it's not one's better or worse. They're just different. But that's not what we mean by homogeny variance. It's the score that we're measuring. Does it have about the same spread, or is it like more similar among men and women are like all over the place? Like, I don't know if we looked at minutes spent reading romance novels. Men are probably really tightly clustered around 0. And women, we're going to have a lot more variety. That would be heterogeneity of variance. Okay, so there's these 2 types of t-tests we can do. The t-test looks similar. Here's the t-test. To make t, both of them, what goes on the top? The difference between the 2 means. D bar goes on the top of both of those. The difference between the tests is what we are dividing by, what goes on the bottom. And it's these different kinds of standard errors. Whether we can assume the standard deviations are roughly the same, or we're assuming they're different. So you have to make this decision before you know how to do your t-test. Are we going to assume we have homogeny of variance? They're equal standard deviation? Or are we going to say, we can't say that they're the same, we need to do separate variance test. Now, there is a test to test if you have homogeny variance. So I said roughly variance more than double one of the other ones. The bigger variance is more than double the smaller one. But there is this Levine's test that you can run that will actually test that for you without you having to eyeball it and do this double rule. And we are going to run it in R. The crazy thing about this is it's like a chicken or the egg, what comes first. Levine's test is an F test. Have we learned about F tests yet? No. So we're kind of throwing Levine's test at you, but it's a type of F test that you don't know anything about. F tests, just let me tell you, they're like a t-test and a z-test in that it's a test statistic that has a table. We will learn it in a few weeks. It's table, one of the next tables in your book. We've done A1 is the z table, A2 is the t table. I think there's another one before we get to the F table, but it's coming up. But the interesting thing about an F table is it doesn't, Z has no degrees of freedom. T-tests have a degree of freedom. F-tests have 2 degrees of freedom. And we number them 1, 2. They're called numerator degrees of freedom and denominator degrees of freedom. What does numerator and denominator ring a bell? Fractions. So an F score, an F test, is made by doing a fraction. So that's why we get numerator and denominator degrees of freedom. We will get into it more, but just know an F test has 2 degrees of freedom, and then it gets a p-value to go with the score. And that's what we're going to get out of R. And I'll show you how to read the output. So we're going to run Levine's test to decide, can we do the pooled variance test, or do we need to do a separate variance test? Also, a lot of the homework questions tell you which one you should do for practice. Okay? So the t-tests always have D bar on the top. The bottom is different. So let's look at this top one first. Let's see, this formula for standard error. We have the square root of, what's going to be S1? What does that stand for? Standard deviation of sample 1 squared. And over here we have standard deviation of sample 2 squared. What's N1? Sample size of group sample 1 and sample size of group 2. Okay. Now, when we looked up a in the t-table, we had to have degrees of freedom. When we had a one sample test up there, you can barely see it up at the top. How do we find degrees of freedom? Sample size minus 1. Now with 2 samples, it depends on how you're doing it. Now I want you to look down here. Pooled degrees of freedom. How do we find that? Add the sample sizes and subtract 2. So it's like you subtract 1 from each sample size and combine it, okay? That's fairly straightforward. This one is a little different. So the pooled variance test came first, and it's straightforward. We have exact degrees of freedom. But the separate variance test, it's trying to take into consideration, so a t-test, the regular t-test assumes that we have equal sample sizes and equal spreads. Now, depending on how unequal the sample sizes are and how unequal the spreads are, that changes the degrees of freedom. If we have exactly the same sample sizes and exactly the same spreads, the degrees of freedom will be that number right here, the combined sample size minus 2. But if the samples are very lopsided in terms of their size and spread, our sample size, our degrees of freedom could be very different. So let's see, it says MIN N apostrophe S. What do you think that means? The smallest, minimum, the smallest of the 2 sample sizes. So if I have a sample size says of 10 and 30, what's the smallest the degrees of freedom could be? 9, because it would be 1 less than the smaller sample size of 10. Now, the degrees of freedom is a decimal number somewhere in between. So let me see. If I had sample sizes of 10 and 100, what's the, if I did the pooled variance test, what would our degrees of freedom be? You would combine those and subtract 2, so that would be 108. Now, if I do the degrees of freedom for the separate variance test, my degrees of freedom, the highest it can be is 108. The lowest it can be is 9. And it's probably a decimal number in between there. Now, there is a formula in the extra material in your textbook for finding that. It's Welch's formula for degrees of freedom. I'm not going to make you do it by hand, ever, okay? So on the homework, when it says degrees of freedom, Jeremy and I checked this today. You can put any number in between there, 9 and 108. Now, if I'm going to look up the critical value, which number should I look up? What's the most conservative? To go on 9. Okay? In the real world, the computer uses that Welch's formula, and it will spit out degrees of freedom equal 13.457. Degrees of freedom can be a decimal number. What do you do if you have to use the table with the decimal degrees of freedom? Round to the closest one. Yep.
Is there a preference to round up or down, or just go around?
Preference is to round down because it's more conservative, but it's not going to make a difference on the homework. Shouldn't. If you ever get a homework question marked wrong and you think it's just a rounding thing, or you use the wrong line in the table, what should you do? Email me and say, on question number blah, on homework number blee, I think that I got it wrong from rounding. Will you check it out? And I will check it out and give you the points if that's the case. Okay. All right, so. Now, the degrees of freedom are more straightforward on the pooled test, but actually calculating the t-statistic is more straightforward in the separate variance. The separate variance, you plug them in here. Now, to do the pooled variance, let's look at what's on the bottom of this fraction. Inside the parentheses e's, we have 1 over the first sample size plus 1 over the second sample size, but what's out here? The pooled variance. How do we get the pooled variance? There's 2 different formulas. This formula works if you have identical sample sizes. This formula works if you don't have identical sample sizes. So there's lots of, this is why at this point we start doing more of the assignment in R and less of it by hand. Every year I teach this course, and when Tyson teaches this course, anyone teaches this course, one of the big complaints on the teacher evaluation is, this class felt like an R class, and I thought I was here to learn statistics. Guess what? You cannot do this level of statistics without a program, because you will die before you get done doing this stuff by hand.
One rounding error in something this complex gets you so far off.
It gets you so far off. What do you want to do this kind of stuff if you have a sample size of 150? You don't. So we're using the software to make your life possible and easy. You can't, whether we use R or SPSS or Stata or SAS or Statistica, you have to use some kind of software to do this in real life. It's just not. So yes, we spend a lot of time on software, but hopefully in this chapter we're going to spend a lot of time how to write it up as well. What do you push to get the output, and then how do you make sense of the output once you get it? Okay. Homework. All right. Do we want to do this first one, or are you guys good on the first one? You tell me.
My issues were much further down.
Much further down? Okay. Anyone else want? Anyone else have an opinion they want to voice? Speak now. Further down?
So more like question 3-ish.
Which is what? Now, when you tell me the question number, would you tell me it's like 7B? 7B.
I have 7A.
7. Anyone have? Yeah, let's do 7A questions. So this is the only 7A question. Is this one?
A question 8.
8. Okay. Yeah, let's go over this one because we can go quick, but I want to go over it. Okay. I'm going to open this in the PDF viewer because then I can write on it and scroll around. Oh, that's not what I want. Oh, not that. Okay. Okay, here we go. 7A number 7. So this is the first where your homework starts, right?
I think she's asking about one where you input the text, like we write about what's a true experiment.
Oh, this one?
Mm-hmm.
Okay, so it looks a little different. We had to write it a little different into the homework. Yeah. Seven. Okay. Questions. So this one?
Yeah.
A true experiment. What does something have to be in order to be a true experiment? What has to happen? We have to have random assignment by the researcher. The researcher has to decide at random how to put people in groups. Now, everyone can have something different here. Do you have an example? Is there one you think might work? Does someone want to give their example? Yeah.
The true or not, or the quasi.
True experiment, yeah.
So I put like an example would be randomly selecting 200 students at a university through like a number generator with the registrar office and having all students take a pretest on knowledge of mental health services and then providing a curriculum for only half the students and then having them take a post-test.
Okay, so the big thing there is you would randomly select half to get the training or the curriculum, and the other half would not get it. And it's the researcher who decides and assigns who does and does not get it. The big key for part A to be right is that it has to be the researcher that's deciding who goes in the treatment, who goes in the control, or who gets A, who gets B, whatever the difference is between the two groups. What about the quasi experiment?
So there was an example in the book in which the experimenter selects a group of exercisers and
Uh-huh.
a group of people who.
Yeah, so the people in the study are already, before the study started, either being exercisers or not exercisers by some criteria. They chose, or their life, or their genetics, or whatever. It wasn't the researcher who said, you're an exerciser and you're not. They were already that way before the study started. They were already either exercising or not exercising. Often we say they self-selected, but it's not like they said, I'm going to be an exerciser, probably. It's just, what happened in their life at that point. Sometimes we say exposed or unexposed. Have you been exposed to sexual trauma or not? It's not the researcher who decides who's in which group. It's outside of the researcher's control. If you have a sample and you divide them into male and female, or if you divide them into young and old, it's not the researcher doesn't randomly assign gender or age or status or whatever it is. It comes from something that's outside of the researcher's control. It could be diet. They're either healthy eaters or not healthy eaters, not because of what, versus a true experiment, you would enroll people and then you'd say, you guys get to eat this food that's healthy and you guys get to eat this food that's not healthy. That would be an experiment where you assign the diets, versus a quasi experiment or observational study is where the diet is chosen not by the researcher, it's just what they eat because of self-selection. Again, self-selection is kind of makes it seem like people do it on purpose, but it's not always purposeful. Yeah?
Isn't there an element of quasi-ness to kind of every, like, I guess what I'm saying,
Mhm.
like, say you're just taking in years of school.
How many? Now, if you measure something like years of school, that's going to be observational. It's only experimental if you assign, like you put, sometimes you can't do this, but imagine you took kindergartners and you assigned them to a good school and a bad school, or you made them go to grad school and you prohibited them from going to grad school. I mean, that's unethical, but that would be a true experiment, versus a quasi-experiment or observational study would just be recording what they did.
Okay.
Yeah.
So,
It's who makes the distinction. Yeah.
So for the conclusion,
Uh-huh.
conclusion about the quasi experiment, so experimenter should explain about their
Yeah.
research design.
Mm-hmm. Your design, you can still do the same math. You can still do independent groups t-tests in both of these situations. It's what you can do about your conclusion. So in both of these, like the diet, whether the researcher gives the food to the people and makes sure they follow the plan that they randomly assigned it to, or they just record the food that they're already eating based on their own, you can still make comparisons between healthy eaters and non-healthy eaters, but what do you do with that significance? If it's a quasi-experimental, an observational study, you can just say there's an association. You can say there is a difference. Healthy eaters have lower heart rates. But you cannot say healthy eating causes lower heart rate. You can in observational studies, quasi-experimental, we can link things together and say they're associated. But we have to have an experiment to say one thing causes another. This is a huge distinction. This is, if nothing else, this is like probably the most important thing we can get out of this chapter. So it will be on the test for sure. So again, in observational study, we can establish associations and say things are connected. But we can't say they're A causes B unless we have randomly assigned A and then observed B after the fact. So we have to randomly, so in smoking, how will we do a true experiment in smoking? We would assign people to, you have to smoke, you can't smoke, and then see what happens to their health in the future. That's the only way we can really establish smoking causes health problems. If we just gather a sample and see who already smokes and doesn't smoke and how their health is, that's an observational study, we can say smoking is associated with health problems, but we can't make that cause and effect because in an observational study, this is the reasoning, there can be unforeseen confounding factors. Yeah?
That's what I was talking about, I think, because I was thinking like, well, like say here, health increases with, say, not smoking, but also does the education level of your parents or things like that.
Yeah, are smokers less educated or have different genetic, you're more susceptible to being addicted to nicotine if you have a certain genetic composition that makes you less healthy. This was a big thing when smoking was very first starting to be connected to health problems through observational studies. Fisher, the Sir Ronald Fisher of statistics fame, the father of statistical testing, was a pipe smoker, and he vehemently opposed all evidence that smoking caused health problems. He thought it was bogus because it was all based on observational studies. Because he said, there are lots of different confounding factors, a third factor that could cause those things to be linked that have nothing to do with a causal relationship. And so he didn't believe it. This was why when we have observational studies, we have to have a mountain of studies, plus a lot more stuff to like dose effect and timing studies to show that they're in usually animal models to show that there really is evidence of a cause and effect, because observational study alone cannot establish causation. You've got to intervene in a true experiment and randomly assign said thing to show its causes, anything. So even if your hypothesis is A causes B, if you cannot randomize the A that causes B, then your conclusion can only say that A and B are associated, and you cannot use any language that kind of makes the case that it's caused. You can only say that they're linked. A really famous example is, just using stats classes all the time, it has been proven time and time again, year after year, that in Florida, days where more ice cream is sold, there is more drowning. Ice cream sales and drowning deaths are linked. On days we observe more ice cream sales, we also observe more drowning. Ice cream causes drowning. What's wrong with the logic? It's based on a third confounding factor, and that is weather or temperature or, there's a third factor that we're not controlling for. I think the one on the homework, maybe next, I think it's one of the coming chapters. Shoe size in children, shoe size is associated with reading. Bigger shoes equal higher reading scores. Bigger feet make you a better reader.
Your feet are bigger when you're older.
What? Age. If we're looking at like kindergarten through 5th grade, as kids get older, their feet get bigger and they get older. Just because we see two things, observe them co-occurring, doesn't mean that one is causing each other. We would have to randomize shoe size, which is really hard to do. Or we would have to use age as a control variable in a regression model to factor out the effect of age. After accounting for age, is there any association between shoe size and reading? There isn't. But this is what I mean. This is the key point. In an observational study, we can just link things as associated. We need an experiment where we randomly assigned the treatment or the exposure in order to say it causes the outcome. It's a good one to focus on. Okay. And I think that was actually 7B, number 8. It was mislabeled in here. Okay. Okay. How about this one? Seven B, number 3. Any questions? It's mighty quiet. No? What's the first one you guys have questions on?
7B question 6.
7B question 6.
Before question 4.
Question 4. Okay. Question B number 4. So we got the blood pressure on runners and non-runners. Is running observed or experimentally randomized? The running, whether they're a marathon runner or not, is an observed grouping. Okay? And we're looking at their blood pressure. Okay. What's the question?
Was this one of those ones with the degrees of freedom that any answer's okay?
Yeah, so this is
I
one.
wasn't sure.
Yeah, so in this one, it says in the book and in the Canvas, it says use separate variance, not pooled. It tells you on purpose to do the separate variance. And the separate variance has that degrees of freedom that's between the minimum sample size -1 and the combined sample size -2. So in this one, what are the two sample sizes? 60 and 60. So what's the smallest number the degrees of freedom can be? 59. And what's the biggest the degrees of freedom can be? 118.
So it has to be between those.
It has to be a number in between those. It could be equal. It could be in between. Yeah. So I think it'll mark it correct if you write anything between 59 and 118. To know exactly what it is, you'd have to do Welch's, like the grape jelly, Welch's formula.
Is that the same for 7A, the degrees of freedom? Do we just,
7A.
we were just there, so.
Oh. Yeah, if it's any of those that tell you to do the separate variance test, if they tell you to do the separate variance test, the sample sizes or the degrees of freedom is something in between that range. And again, the homework on Canvas will accept any number in that range. Yeah. Until you do the R part, and R will actually spit out the decimal number. Okay, any other ones that are not using R? Oh, the next one, right? Okay. So this one is same information, right? This one said separate variance not pooled, and this one you're supposed to do the separate variance not pooled. Oh, this is just doing the other confidence intervals? Yeah.
Where are we looking?
Let me look at the Canvas one. There. Any other questions about this 7B4?
You want calculating the T critical value.
The T critical value, yeah.
Should we be going for should we be using the degree of freedom which is just around this?
Yeah. So this is a good question. So what degree of freedom, if the degrees of freedom is this range thing, which number do you use for the table? Use the smaller one, because that's more conservative. So on this one about the marathon runners, what's the most conservative degrees of freedom? 59. But 59 is not on the T table, so use, what's the closest one? 60.
Did we need to do that?
I didn't think we needed it, to be honest.
Did we need the critical value?
I don't know. We need a confidence interval.
For the next one.
For the next one? For number 6 we do, but number 4 we didn't, right? Yeah, number 4 doesn't ask you to find a critical value, but number 6 does.
But since it's pooled, isn't there only one option?
In 6, you're not supposed to pool. Oh, 6 is used pooled, yeah. In 6, you're supposed to pool. Yeah. Yeah, so here's number 6. 6 is the saliva enzyme levels, and it tells you to perform a t-test, and it gives you the pooled formula. Yeah, the pooled variance formula in number 6. So in number 6, our degrees of freedom is an exact number. It's the combined sample size minus 2. What are our sample sizes? 12 and 20. So 12 and 20 added together are 32 minus 2, so 30. So for this one, critical value, you use the line for 30, degrees of freedom 30. Yeah.
Okay, this one was the one I posted a question on the homework.
Mhm.
I got a large T, and I'm not sure everyone else did, so I just want to make sure I didn't mess it
What
up.
did you get for the T?
I got 4.4 something, 4.64 something.
I got a different number. Let's see.
Okay.
Shall we see? Okay, so I'm going to go to this.
Like 3 times.
Yeah.
Because you got a different 6 for it, though. Okay.
Okay.
That's what I got. Okay, so I was just
Well,
wondering.
that's what I got the second time. The first time I did it, I had like a
Okay.
point one something.
Okay.
This is
So it's question 35, 36 on the homework.
35, 36 on the homework. Yeah, this is why I don't like the homework the way it's numbered, and this is the. We have a solution. I'm meeting with the campus curriculum Canvas person tomorrow at 4 to make sure. We got to make sure it works before I show you. Okay.
I got something crazy like that.
So here's the worksheet packet. So the neurotic people, how many neurotic people are there? This would be me. I would be here. I want it here, though, so I can write on it. Let's see.
7B question.
Okay. There we go. Oh. There's 12 neurotics. Get into it. There's 12 neurotics. Oh, no, I don't want the signing one. I want it closed. How? It's been too long since I did this. How do I do the write-on?
I think there is a icon that has the one next to it. Edit.
This one?
Yeah, I think so.
This is the sign.
That's not one. On the other side, edit. Yeah, this one.
No, I don't think that's it. Is it?
4.6.
No. I used to do this all the time.
Yeah, I didn't remember. I did all of them.
Oh, I know. I know how I can do it. Okay. I can do it in here. Okay. Get the right program. Come on. Where's our neurotic people?
You go down.
Is it?
There you go.
Yeah. There we go. Okay. I can write in here. Okay. Because I pushed that button. Okay. So there's 12 neurotics and there are 20 low anxiety. So our degrees of freedom are 12 plus 20 minus 2, which equals 30. Okay. What are our two averages? Our neurotics average is 3.2, and our low anxiety people are, our chill people are 2.3. And the standard deviations, and 0.4 respectively. So this number here, this is our D bar, the difference in the two sample averages. What do you guys get for that? 0.9. Okay. Now to do standard error, we got to first pool our standard deviation. Now we have to use this funky formula because we have unequal group sizes. So what's n minus 1? n1 minus 1. That's 11 times what's s1 squared? 0.7 squared. So this is 0.49. Plus the second sample size minus 1. 19 times the second standard deviation squared. 0.4 squared is 0.16. And it's all divided by the combined sample size minus 2. Okay? What do you guys, when you crunch all those numbers, fun times, what do you get? 0.281. I concur with you.
So far, so good.
Okay, so good. So that's the number that goes down here. So to get the standard error, I need a square root of that number we just calculated in the red times 1 over 12 plus 1 over 20. Ugh. Button pushing. You guys love R, don't you? You love R, yeah. Okay, use 4 decimal places if you can while working, and it'll make it more exact. So what do you get here?
193.7.
I put down 0.1936. I used 4 decimal places throughout. I'm seeing nodding. That's good. Good, good. 0.1936. Okay. So, to get our t-score is the observed difference divided by that standard error. So we're going to take our 0.9 and divide it by that 0.1936. And that's where you get what number? Not 8.4. 6. If we round it off to 2 decimal places. I always use 4 decimal places while I'm working it out, if there are 4 decimal places, and then 2 on the answer.
So I got it right.
Yeah. Oh, you did get it right.
Yeah,
Oh, sweet.
I did get it right.
So when we do our critical value, which number are we going to look up in the t-table? 30. Are we going to do 2-tail or 1-tail? It told us to do 2-tail. Anyone look it up in the table? 2.042. So that is how big our test statistic has to be in order to be significant. It's got to be bigger than this big or bigger to be significant. So what do we say? Significant.
So the neurotic people would have more of the enzyme.
So if we look up here, we got these 2 groups. So our conclusion is these groups are different. Now, oh, we didn't fill this out. What's our null hypothesis? Same. What's the same? The difference is 0. So you can either write it that d bar equals 0, or you could have written it mu1 equals mu2, or you can write it mu1 minus mu2 equals 0. All of those are writing the same thing. These are the 3 different ways. D bar equals 0, mu1 minus mu2 equals 0, or mu1 equals mu2. Now notice, in the hypothesis, did I use x bar? Why did I not use x bar? Null hypothesis is always about the population. You should always have your Greek letter mu here. Your data you got is sample-based. Sample statistics, that's the x bar. But the hypothesis is always here. So what's our alternative hypothesis? Not equal to. So you could write any of those the same way, but with a not equal. That allows for the 2 tails. Now it's important. This is a really important tidbit here. Even though our alternative hypothesis allows for 2 tails, either direction, when we write our conclusion, we need to specify which direction. So we have statistically significant evidence that the neurotics have higher level of enzymes in their saliva than our chill people. How did you have to write it into Canvas? That's a question.
It's open response.
Oh, it's just an open response?
Yeah. Then it asks you about the type of error you'd be making.
Ooh. Okay, so there's, state your conclusion. So our conclusion is neurotic people, there is evidence that neurotics have an elevated level of this saliva enzyme.
Do you have to put average in there?
It is on average because we compared averages, but you're not going to get marked wrong. People usually don't get too nitpicky about that. Really, what would the newspaper article say? What would the headline be? Neurotics have elevated saliva enzyme levels. That's what our conclusion is in a nutshell. There is evidence which group is higher or lower. Even though our alternative hypothesis allowed for 2 directions, our conclusion states which direction we found if there was an effect. So which type of, did we have a positive or a negative result? We call that a positive result. So could we have a false positive or a false negative?
The Christians said the part A.
That it means this one. Yeah, they're not. It's the one before. This is why I don't like the way these are entered.
Because
Yeah.
It's not a textbook, and the textbook has
Yeah.
part A, just like.
Yeah, the textbook has this is part A and this is part B, but they're not labeled in here right, and they're just it's a mess. That's why I gave you the printed out version, and those are labeled so you don't have to open the textbook if you don't want to. Their A and B are labeled on that. So what type of error could it be? A type 1 or a type 2? The only thing it could be a type 1, because we said there is a result, so it could only be a false positive. Can't be a type 2 false negative, because we didn't have a negative result.
So what's the, on 39, what's the p-value, like how do you know?
So on this one, we don't know what the p-value is exactly, because we don't have an exact table.
Calculate it in R, right?
You could, if we're using R, it'll give it to us. Let's go back to the formula sheet here, or the tables. I'm going to look up that T table.
So it asks for
Levine's p-value in that one? Oh, the next one. Yeah, we'll do the next one. Yeah.
I couldn't understand that. I couldn't
Okay.
understand what it represented.
Yeah, I Googled something, and I'm like, oh, okay.
Yeah, I couldn't understand what that
I didn't
value
either.
was showing.
Okay. Let's see.
Yeah.
Here's our T table. Okay. So on this one, how many degrees of freedom do we have on that last one? 30. Oh, I need to go back. Okay. There. So here's the line 30. So we're going to look on the line 30. What was our test statistic T? T was 4 point something. Where does that fall on this line of 30? It's off the chart on this side. So if you look up straight up, what's going to be our p-value? We don't know exactly what it is, but we know that it's less than, because it would fall here. Now, what if our test statistic for 30 had been 2.0? It would have fallen between these two, 2.0, if it had been 2.0. Then we could say our p-value would be between 0.05 and 0.10. With this T table, we can just say our p-value is between these two numbers, or less than the smallest number, or bigger than the biggest number. We can't get an exact p number off this table, which is why most of the assignments using R, which is the next one, right?
Yeah, and it's the different, the Levine's.
Levine's test.
I wasn't sure, like,
How to read that?
yeah. How
Yes.
to interpret that, like,
Perfect
if it's
question.
greater than 5, this, if it's greater than, I don't know.
Perfect question. So this is chapter 7 assignment. Okay, so I'm opening R. This is so great. This is exactly what I want our class to be like. So this is question number 1. Okay, so I'm going to come down to, so here it is. Run everything above. Okay. Okay. So this is how we run Levine's test. We have our data set, and we pipe it into CAR, which is Companion to Applied Regression, and ANOVA, Levine's test, and then we put the continuous variable we're testing, and then the tilde wave, and then the grouping variable on the other side. So our two groups. And we say data equals dot, because it's piped from above. And by default, it does median. I don't know why. It seems so random in my head. So we have to say center equals mean. So this is the output. So how do we read this output? That's the question, right? Okay. So this is how you would write, no, not that one, this one. Okay, I'm going to choose yellow. So this is the degrees of freedom right here. They're stacked up because remember I said there's 2 degrees of freedom, the numerator degrees of freedom and denominator degrees of freedom. The numerator degrees of freedom are 1. The denominator degrees of freedom are 98. Now when we write this APA style, you say F, and then we do the parentheses for the degrees of freedom like we do on the T statistic. But which one do you think comes first? The top one comes first. And then how can we put the second one? A comma, and then the denominator ones.
So that's, oh God, I gotta read that problem.
So we do capital F, and then we list our degrees of freedom. The top numerator degree of freedom and the bottom numerator degree of freedom with a comma, and we usually put a space in there. And then space equals. Now an F statistic can be bigger than 1. So we do need that 0 in front of the decimal place there. And we usually do 2 decimal places on a T or an F or a Z. And then p-values, we usually do 3 decimal places, but no 0 in front of the decimal.
So I have
Yeah.
a question, because I'm jumping
Uh-huh.
because there are so many steps in these questions.
Yeah, there are.
And so when it says to write in the APA,
Okay.
like by the time I get to the question that says write in APA style, I'm not writing that. I'm writing after the next set of.
Yeah, well,
Right.
you need both. So when you write up a t-test, first you need to say a t-test was performed to compare the mean level of, what are we comparing here? The mean heart rate, the baseline heart rates of the 2 genders. So you say what test you're doing. A t-test was performed to compare baseline heart rates between men and women. Say the test you're doing. So that would be the first step. 1, what is the test? And the variables that are involved. A t-test was performed to compare baseline heart rates between men and women. Step 2, you have to deal with any assumptions of the test. What are the assumptions of a t-test? They're the same for a 2-sample kind of as a 1-sample, except for 1 extra one. Homogeny of variance is a big one. This is the big test we have to do. So the assumption, we have to address the assumption. Now, this is Levine's test that is testing if we have homogeny of variance.
And how do you know what's the threshold?
What's our p-value threshold? How do we judge p-values? What's our usual value we cut it off at? 0.05. So is this significant? This is not significant. So this is how you interpret a Levine's test. If this is big, that's good. Because it says there is no significant violation of homogeny of variance. So you would say no significant violations of homogeny of variance were found, comma, and then you write this.
Can we abbreviate HOV?
Yes. Can you do abbreviate HOV in when you write an article or no? The first time you have to say it, but nobody abbreviates homogeny of variance because they only ever say it once, if ever. That's the part that most people leave out of a write-up, but I want you guys to do it because that's the focus of this class. So a t-test was performed, a 2-sample independence group t-test, if we want to be really verbose. T-test was performed to compare baseline heart rates for men and women. No significant violations of homogeny of variance were found. F, parentheses, 1,98 equals 0.10 with a p-value of 0.751.
Do you put spaces?
We do put spaces.
Before and after the equal?
If I was doing, let me mark where you'd put the spaces with green. So you usually would put a space on either side of the equal sign and after the commas. That's usually where we put the spaces, around an equal sign and after a comma.
And then you would, to report the confidence interval.
So that's reporting Levine's test. That's not the t-test.
So you just go to the next.
Yeah. So first we say what test we did. We did a t-test on which variables, baseline heart rate and gender, by gender. Then we say our assumptions, which is Levine's test. And you can say Levine's test found no significant violations of homogeny variance. Is there only one way to write this? Which words do you have to use? I don't know. Depends on who reads. I'm good with this. But it would be nice if you said Levine's test, especially on a dissertation. That would show your committee you know what you're doing. And so the third thing is to report the t-test. And yes, This is a multi-step process. This is not what we do in kindergarten. Yeah, there are lots of steps. The good news is these steps are going to be the same when we go to ANOVA. We're going to say what tests we did with what variables. We're going to discuss assumptions that we met or violated, and then we're going to report the test itself. Okay? So that stays the same. So the Levine's test is an assumption test. Now we're ready to go to the t-test? Okay? Anyone have any questions on Levine's test? Now, what will we do if this was a tiny number? Then we would say significant violations of homogeneity variance were found. So what does that affect our t-test? Are we going to pool it, or are we going to do separate variance? If this is not violated, we can do the pooled variance. If this was a tiny number, we would need to do the separate variance test. So that's why we do Levine's test first, to decide, can we do a pooled equal variance, or do we need to do a separate variance test for the t-test? Okay, so here is the t-test. Okay, so does this look very similar to Levine's test? Let me get them both on the screen so we can see them at the same time. Here, I'll delete this so we can see it all together. Okay. Okay, look at the two code chunks. How similar are these? How do they start? They start with the data set. They pipe it into a function. What's the first thing in the parentheses? This formula, continuous variable we're comparing, tilde wave, two-category grouping variable. That's the same. What's the second thing that comes in the parentheses? Data equals dot. That's the same. In Levine's test, we have this option center equals mean that we have to do. In a t-test, if we're doing the two-group t-test, this is different than the one-group t-test. We have to say var dot equals true, or var dot equals false. Now let me flip. This is where I'm going to flip back to the formula sheet. Where's our formula sheet? We're going to all have a copy of the formula sheet, right? That's what's right here, see? If we can assume we have homogeneity of variance with Levine's test, then we say var dot equals true. If Levine's test failed, or we have very lopsided sample sizes, we need to do var dot equals false. Put it on the formula sheet. So what are we going to do this time? True, because homogeneity of variance, Levine's test, had a great big p-value, so no violations found. That's good news. Okay. So notice, what does it say here? Two sample t-test. I'm going to change this to false, and I want you to look at how the output changes. Oh, look at the degrees of freedom here. What are our degrees of freedom? What was our sample size? There's 100 students in Eno's data set. So what's the degrees of freedom? 100 minus 2. That's if we do true. What's going to happen if I do false? Now what does it say? How did this title change? It says Welch's. What do you notice about our degrees of freedom? It's a decimal number, and it's somewhere in between 100 minus 2 and it's not 50 minus 1, because it's not 50 men and 50 women. It's a little unequal. I don't remember what the number is. But it's a decimal number that's less than 85. How much less is it than 85? Or wait, what was it? 90, 98? It's somewhat less. Is it all the way down in the 40s? No, but it's a little bit less. Okay, so I'm going to change it back. Okay, how do we write up the t-test? Oh, come on, do the whole screen. There we go. So the t-test is right here. So notice it tells us down here, there's the average for females. What's the female average? 73. What's the male average? Almost 71. Which one's higher? Women. Okay, what's our p-value? Really, really small. So what does this tell us about men and women? They're different. So how would we write? What would we write for? Anyone want to give it a go?
So there was
A
difference.
significant difference
In baseline heart rates.
in baseline heart rate. It's hard to write with this. It's like writing with a crayon. So I'm sorry, it's sloppy.
Men having lower baseline heart rates.
Was found. And how do I back that up with my statistics? So I would say, to back it up, I would do my T of, with 98 degrees of freedom equals, what number do I use for, is T equal to? The T number is right here, 3.87 if I'm going to 2 decimal places, comma, P, what's my p-value? What am I going to write? Less than 0.001. So a significant difference in baseline heart rate was found such that men had a lower rate than women. Is that the only way to write it? Heck no. Every one of you could write a different sentence or sentences that would say that with different words. What's the main idea we need to get across? They're different. Women are higher.
We also have to put the confidence interval.
Yeah. Oh. Men. So what's one way we could write a whole nother sentence? You know, these are the kinds of things you have to write these several times to kind of get a flow for it. I don't care if it flows or not.
If you wrote it in a sentence that ended with the p-value, so.
So what? Read your sentence. Let's see.
So I put the results of the t-test indicated baseline heart rate for females was higher than males, and then I put the means.
And then you put the means.
And was statistically significant with t.
And was statistically now the t and the p-value do not go in parentheses.
Yeah,
They're just with commas.
There's commas.
Yeah,
And
it's
then
weird.
After the p of less than 0.001, I put another comma with 95% CI
Yep.
in the brackets.
Yep, you could do 95% CI and then bracket, and it gives you it over here, right here, in the output. 95% CI and then 1.14. Oh, mine's like, can I go up here? 1.14, comma, 3.56. I can't, insert text on my writing, so it's sorry. And then you have another comma after that. Now you could rearrange that sentence and make it flow smoother. The key idea is, yes, women are faster heart rates. That's what you need to get across. And you need to at least have this pink stuff, this melon stuff, orangish stuff, and the means are nice to have, but usually the means are in a table, like table 1, the descriptive table. So you don't always have to put them in the sentence if they're already in the table. But the pink and orangish stuff, that has to be in your sentence some way, form. Yeah?
Does that comma, is that how you complete it, or does that mean there's more?
That means there's more to come. If it was the end of the sentence, then you put a period at the very end, wherever it ends. If you guys ever want to You know, put on the discussion board, hey, I wrote this. Does this sound okay? Did you get something like this? I read those things. I check the discussion board every time I get done with a meeting, which today has been like constantly in meetings. But you can check, I love how these guys have been really active with checking answers with each other. The swim meet, there was a lot of action right in the middle of the swim meet Saturday. So that's why I didn't get on it. I was on deck, yeah.
So this is still the Levine test, right?
Nope, this is the t-test. The Levine's test said, can we do pooled? Did we violate homogeny of variance or not? Because that's going to tell us whether we, now, should we put in here that we did a pooled t-test? The pooled t-test is like what people think you did unless you say you did a separate variance test. Yeah. It's not the default in R, though, so that's what's confusing to me. So if Levine's test is not violated, you have no violations of homogeny of variance, then you can go right on to this. If Levine's test was significant, and you had, which means you had violations of homogeny of variance, then you would need to do, say, so a separate variance test was conducted, and then you're going to have those decimal degrees of freedom because you're going to do Welch's version of the t-test, which is to correct for that violation of homogeny of variance.
So the confidence interval that this gives is centered around, I don't know.
Yeah, this is a great question. What is this confidence interval? It's a little 1 to 3.5. What's 1 to 3.5? The difference between these two. Now, this does not spit out D bar. How would we find D bar? We're going to have to do it by hand. D bar would be the difference, 73.28 minus 70.93. And that would be the difference. That difference is the middle of the confidence interval. So how much faster are women's heart rate? Between 1 and 3.5 beats per minute faster. So this confidence interval tells you about how much faster women are than men, the difference between these two. It's centered around the D bar, the actual observed difference.
So if one of these numbers is positive and the other one is negative, it means that it's not significant.
Right. That was great. I think there's one like that on the homework.
Can you repeat that?
Let's look at the next one, shall we? Okay. So let's look at the next one. Okay. So here's Levine's test. What would you say about this Levine's test?
It's
It's good to go.
or it's not significant.
There is no evidence of significant violations of homogeny of variance. No evidence of violating homogeny of variance. So should we do separate variance or pooled variance? Pooled variance. So we say var dot equals true. Okay. What about this t-test? Look at what's our p-value now? 0.1 something. Not significant. So what is it telling us about females and males? There's not difference. What do we look when we look at the confidence interval? Goes from negative number to a positive number. So 0 is one of the possibilities. What does 0 mean? No difference. If the p-value is non-significant, you will always have a positive and negative number for the 95% confidence interval. Okay, we are officially out of time. I'm happy to stay for 15, 20, 30 more minutes and answer questions, and I'll keep the recording going, and then I'll upload it. If you have to go, then you'll have that to listen to later if you so inclined. So how would you report the t-test? Well,
No significant difference.
there is no evidence that males and females have different phobia ratings.
So would you still have to put the means of males and females, or if there's no difference, can we leave that
Yeah, I'm not going to get really nitpicky on the grading of this. You need to say something about there being no difference, and you need to include the t with the degrees of freedom equals and the p-value. And do we need the confidence interval?
Yeah, on this one.
I told you to report it, but usually if it's not significant, we don't put the confidence interval. But I ask you to, the directions, the book directions, actually it wasn't me, the book directions tell you to write it with it. But the main thing, do you need the means? They're nice to have, but I mean, these look really different, right? 3.5 and 3, those numbers look different. But are they, can we prove that they're different in the population? No.
So if it was a significant difference, you'd want the mean.
Yeah, if it's a significant difference, you want the means and you want the confidence interval, and we'll learn next time to put the effect size as a Cohen's d. But we haven't learned that yet, officially. Yeah. Good questions. Oh, yeah. Yeah, no, you already got 5 bonus minutes. So on that one, you would say, one way to say it, should I read you what I have on the answer key for one version? It's always nice to hear different versions of this. Although females exhibited a higher mean phobia level, mean 3.60, than males, mean 2.93, an independence group t-test found that this to not be a statistically significant difference. Boom, 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 boom. Yeah.
So anytime there's a 0 in your confidence interval.
So if 0's in your confidence interval and you have a negative and a positive number, not significant. Yep. It's going to be due on Wednesday, but I think it's going to auto-submit tonight. So if you can get it done by tonight, that would save you time. I will make sure that there's an extra attempt available and that you can view your old answers. But if it auto-submits tonight and you want to change any of your answers, you're going to have to click retake quiz and re-answer all 100. I can't prevent that. I have tried. And that's why we're going to go to this new system that I'm meeting with the guy tomorrow, because this is like, we can't keep doing this. This is ridiculous. I mean, it's just ridiculous. The whole point of doing it was to save everybody time and energy, not to make our lives miserable. So. Now, getting together and doing this makes it a little less painful, right? That is a great thing to do. The new system that we're going to implement lets you check your answers too.
I got one question.
Yes.
It's like the very last one. Explain the connection between the 99% confidence interval and your decision regarding the null at a 0.01 level. Is that just you wanting us to tell you that if it is 99, then like
If the 99%, so we talked about it as far as 95% confidence and 0.05, but the same thing is if the 99% confidence interval has a negative and a positive end, so 0's in it, that means it's not significant at the 0.01 level. If it's the 99% confidence interval, 0 in it is paired with significance at the 0.01 level.
Okay.
Yeah. So if 0's inside the interval, then it is not significant at the partner alpha level. If you're doing a 99% confidence interval, then our significance is at a 0.01 level, because 1 and 99 go together.
I just didn't know
Yeah.
what exactly.
Yeah, that's what it's trying to ask.
What we round up.
Yeah.
Because I use your overlays, but I didn't.
Yeah. It's, because they're partner levels. If we're doing a two-tail, that's only true if we're doing a two-tail test. Got to make sure that's a two-tail test, because confidence intervals are always two-tailed.
Okay, so, hold on. It is in the confidence
That's what they were just asking about.
It's in the confidence interval, which means it is.
If 0's in the confidence interval,
It's,
then
no, 0 is not though.
No.
Because my confidence interval shows -5 to -0.5.
so they're all negative. So 0's not. So it's significant.
So
But
you
not
want
at the
p-value.
0.001 level if so here's what.
Here, let me pull it up. I got it up here.
Yeah, can we just go over that?
That last one. This is the last one.
You're 1 decimal over.
I'm 1 decimal over?
Yeah, for 99% you
Oh, I am 1 decimal over.
Okay. So is it significant at the 99?
Thank you.
Yes.
Yes. Is that less than 0.01?
Gotcha.
Yes.
Gotcha. I added an extra 0.
Oh, you had an
She was
extra
doing
there.
that
Your
back in my
paper,
confidence.
or to the question, I had 0.001 in my head.
Oh, instead of 0.01.
So I was like, oh, maybe it's not.
Okay.
Okay.
Yeah.
And so then the number is within the confidence interval.
If 0 is inside the confidence interval, it's not significant. But where would 0 be? -5, -0.5. 0 would be here. So 0's not in between these numbers, so it is significant. So we know that there is a difference because it's between -0.5 and -5.3. Now, there's for the coffee drinkers and the non-drinkers. So when you write your conclusion, you need to make sure you say, if there is a difference, who's higher, right? Do we say drinking coffee is linked with coffee drinkers have a different level of heart rate? I don't just want to know it's different. I want to know, does it make it go up or down? Then when we do a two-tailed test, people get confused that our alternative hypothesis says it could be greater or less versus our conclusion says which way it actually happened.
How come the p-value, in my other classes, the p-value was like always like simplified down to like 2 decimals? How come we do a bigger one?
We usually report 3 decimal places. Software just does lots of decimal places.
Does it help it be more accurate?
It helps it be more accurate while it's doing things.
Okay.
But then when we report it, some people will only go 2. Most journals will ask for name and Pearson p-values to 3 decimal places. That's what I see a lot of times in journal. Like if you read all the little details at the back of the journal about submissions and results sections.
Okay.
That's kind of the go-to. Some journals will ask for 4, but most say 3.
This is.
In the disciplines I deal with anyway.
Right.
Yours might say 2.
It might, I think we're
Mhm.
probably on the same page there. How do you, if this is off the topic, let me know, but how do you find your minimum N that you need to have?
The sample size?
Yeah.
That's chapter 8. That's what we'll talk about next time.
I based a huge amount of stuff in my life off the study that I read about babies with fetal alcohol syndrome
Mm-hmm.
and finding that, and then I found out that N was 11. I looked deeper into it, and the university that sponsored it was a Seventh-day Adventist university, and they're not. They don't.
Has it been replicated?
Yeah. No, it can't be replicated anywhere. They can't.
All
do
right,
it.
I'm submitting. So I
That's big.
So I'm like,
Do you know, so autism and vaccines. Do you know what the sample size is on the study, the only study that's linked autism and vaccines? 6. And they were friends of the researcher who got disbarred because they were not selected at random. In fact, it came out that 2 of the 4 that he said had autism did not.
Question 9.
oh my gosh.
He lost his license over it. Everyone's discredited it. And yet,
So much damage.
I had 106, so I guess I'll just go.
how many studies? We just barely a month ago had a new meta-analysis that combines like 10 studies with a total of like 30,000 kids. No evidence.
I read one recently that showed that there's a higher incidence of autism in the unvaccinated, but just by a tiny bit. The point was
The effect size was tiny, but it was definitely not in the other direction.
Right.
Mm-hmm.
I'm gonna put back 118.
Mm-hmm.
So,
Yeah.
Question 22 marked mine wrong, even though it was within that range.
Oh, just send me a mess or like a comment. You can make a comment on the assignment or the quiz. Just you can do it there. I'll get that notification too.
That's so weird. Some of these I don't. That's weird.
Oh, no.
Okay. I know, like tons of them are wrong, and I don't know that we went through them. So I don't know. I'll have to read.
Do you want to go through them now, or you want to see if they're really right and I should fix them, or if you want to redo it?
Or if I need to redo them. Because you have the same answer.
Do I?
Uh-huh.
Wasn't sure about the ones before the.
22 and
before 30.
23.
22,
You got 4.4?
negative 4.4.
Oh, no, I have negative. Did I not write negative? That's why.
Yeah, I caught myself on that one.
I had negative. I just didn't enter it there.
I'm so excited.
Yeah, look, right here.
It's 'cause I'm
Negative.
old too. It's like gold.
Yeah.
Oh, my.
It's so nice to have something to hold.
I'm way. Oh, multiple people have. Not moderate. Speed grader. That's what I want. Speed grader. Okay.
So I know that I got the other ones wrong because I didn't insert my negative number. I did
So
that.
Liz.
Degrees of freedom, 22.
Okay.
That one I messed up. I just
Oh, so it should be
transposed
160, not 106.
It should be what?
160, not
my
106.
transposed my numbers.
I didn't have one. I don't think I had 160.
7A, 7B, 7A, 7B.
I have 106 as well.
I have 160.
I wonder if the numbers got transposed because I.
It is 106. You are right.
Okay.
Hey, I'm not foolproof.
I'm just making sure.
Let's see.
Because then that means I messed other stuff.
7A, 7B, and it's the pooled standard deviation should be 106. I have a transposed. Have I told you I have dyslexia?
You know, sometimes I have issues.
You could have blamed your TA.
Huh?
You could have blamed your TA.
Well, he typed in just what I had on the answer key. I have it worked out right over here, and then when I transposed it over there, it's wrong.
Okay. That makes me feel a little better.
Okay.
And 22.
If you think I'm wrong, I'm not foolproof. I'm not the best arithmeticer.
Well, it would have made sense if you had other ones wrong in
That group.
because you used the 106.
So that marked that one wrong.
Oh, look what he put. You can have 59 or 118. He told me it was the range. So I'll need to go in and give you points for that.
I had 118 originally, but then when you said it had to be between them, I changed it.
And that, which one was that?
That's
22.
What was the other one, though?
I don't remember.
This one, right there. 9. This was 9. And then 22 is the first one, the degrees of freedom.
The 23, I didn't put my negative in, so that's going to be wrong.
Okay. Okay, so this one should be right. Okay. Yeah, it should be negative.
Yeah, I have it negative on my paper. So.
Yeah, I'll give you half credit. And then here is
Yeah, it's because I didn't have my negative, so all those are going to be off.
all of them.
Yeah, I can fix it though, because you said we have another.
Yeah.
Class, right?
Yeah,
So I can fix it. You don't.
yeah. And then,
Because they're all going to be off.
yeah. Okay.
So are you just gonna redo the whole thing?
Probably. Because I think that was the only thing I missed was I didn't use the negative. The rest of it should be correct.
Yeah, just that block.
Yep, it's just because I didn't put my negative in. Curse it, negative.
So let me make sure.
But I can, as long as you fix
Let,
that,
yeah,
I
let
can
me
go
make
back
sure
and-
that you have that it allows multiple attempts on this.
Mine says take it again.
Oh, it does. Okay, good.
Yeah.
And I,
I will, so if we start it till you fix it though, right?
yeah, let me fix it.
So I won't start it.
If we already submitted it, will you change it on ours too, like number 9?
Yeah, number 9, and then 22, the degrees of freedom ones. Okay, 2. Okay, so it'll let you have. I'll put 3 attempts. Keep your highest, and through the 12th. Okay, so that's changed. Now I need to change the answers. Edit. Questions. So here it's 7B7 right here. So this one needs to be 106. That one's updated. Now we need our degrees of freedom. So that was, what was the first degrees of freedom?
22.
Oh, but it's like the, oh, here, this one's at the beginning. Right here.
Oh.
Oh, this one, ooh.
That's the wrong one.
7A, 7B. This one should be a range, right?
59 to 118, is that what you're talking about?
Mm-hmm. Nope, this one's, no, it's this one. So it says exact answer, exact answer. Okay, so how do I answer in a range between 14 and 28? And then there's this one.
Which one was between 14 and
7.
20? Question 7.
Okay, I think that's all of them.
And we fixed the 106.
We fixed the 106. Save. You will be able to, if you redo it, you'll be able to upload your R.
Yes, that'll be great. I just emailed you.
Yeah, just do that for me.
That's fine. That's fine, because it's on me, not you.
And we don't need to email you about the 106 if we already submitted
Yep.
it.
Have you already submitted it?
Yeah. Just
Okay.
like 10 minutes ago.
So, but before I made the change. So it'll be interesting to see how it wants to grade it. Because
It
it's,
graded it as wrong
yeah.
because it was before you changed it.
It just loves to. Oh, the other thing I wanted to see. Okay, yeah. So just for kicks, if you want to see, this is how it will look when we fix it. When we get this new is Atomic Assessments app add-in that the university just bought. Did I show you?
Yeah, at the
Actually-
beginning, how we can like check it.
Yeah. So this is, we started doing, so this is what it'll look like. So you go in and say start the activity. And so you can put your thing in here. And then you can say check my answer.
I have one unanswered question. I bet it's not.
And it says, you know, use 4 decimals and then round your answer to 2. But it's like all the questions that go together are all right there.
Where's the link for the formula sheet again?
So if you go to the home page of Canvas, so this has changed drastically. So if you go to the home page of Canvas, if you click on my picture, it takes you to my website. But if you click on this one that says Stat Foundations, that takes you to our classes website within my website. And it has this table down here. And but before the table, it says formula sheet and lookup table.
The introduction and the discussion don't even relate. I said they were like in 2 different articles. It was so crazy.
72 out of 100.
So I had 70s.
Now, all the points for the R, it's like 20 points for R. You don't get any of them.
Still tell me I got question 9 wrong.
I know.
So
Because
even though I waited to submit until after you fixed it, but
Yeah, so I thought that would be the case because it goes on what it was when you started it.
Yeah. So that should be the only.
It goes off the due date and the answers that were in place when you started it.
Yeah, you missed a series too.
I missed that series too. What's going on?
Is that series
What's
wrong?
going on with 25, 26, and 27? Because I have the right answer with the negative 4.4.
Okay. What textbook question is it? 7
7B4.
B4. Okay, let's.
I have 1, 2, 3, 4. Yeah, I had 4 in a row wrong.
7B4. This is the runners, non-runners one?
Yeah, the marathoners and the couch
and
potatoes.
And it's weird because, like, I got the conclusion parts right. Like like was it significant? And yes, I got that right. So I'm thinking it's a rounded thing, maybe.
That's one where you had the equal numbers.
Okay, here's the marathon runners. Okay, so did you get this one? The N, the X bar, and the S?
Yeah.
The degrees of freedom was probably marked wrong.
No, I got it right because I changed it back to 118.
Okay, and then the difference you got,
Negative 4.4.
that should be right.
Yeah, and then the next one I got the standard error I got was 1.653, and that gave it to me correct.
Okay,
But then the next 4 I got wrong.
so the confidence interval, let's see, what is it gonna?
Yeah, I don't know if I did it right. But
The lower bound, that's what I've got.
well, that's an. Oh, damn it!
What?
I didn't do negatives.
Oh,
I did a positive 1.1 and a negative and a positive 7.6.
So you got them flipped.
So I flipped them.
that's because your order is reversed. Write me a message.
But I also,
So the next one,
and then
the 99, you probably put 0.7 or positive 8.73.
yeah,
Yeah, so you just subtracted in the other order.
yeah. So it was just the order I did the
Mm-hmm.
means.
Yeah.
Right?
Yeah,
Which is fine.
yeah. Because it didn't tell you.
Okay.
So, yeah.
Okay.
think that
So
might have
so
been
if
the
I just
same
put
thing that I did.
if I just put a comment on
Mm-hmm. Yeah, just put a comment and then I'll go in and change your score on it.
7B4.
Yeah.
Okay.
Okay.
This is a learning experience for having these be electronically graded.
I have to check now because I just freaked out that I had messed up. But maybe,
And on that one, that's one where the degrees of freedom is between in a range.
So I did the exact same thing.
Where do I comment at? Like I don't see a place to comment.
Like not on the question, like on the assignment as a whole.
Oh.
Like I think you have to scroll back up to the top.
Well, I am at the top. It says back to.
That's great. I don't have to redo all my math. I just have to put
You
it
can
in
send
the
me an
spot.
email too.
Yeah, like it's not giving me a chance. It doesn't give me a place to comment.
Yeah.
Like a regular assignment.
Ah, it usually does.
No.
I'm not a fan of Canvas today.
So 7B4.
Yeah.
Just a little minor.
Yeah. I loved lots of things about those paper packets. I did not love that you got 0 feedback until a week after the test. So I really like the idea that you'll be able to check your answers.
I have a couple questions.
Uh-huh.
That probably.
On the homework? This homework?
Already,
Okay.
Are you guys, do you have any more questions?
No, I'm good. I'm gonna try to use that. I'm gonna try to use that new program to see if I can figure out the power questions that I have
Okay.
no idea how to do.
Yeah?
Okay, so one question I had is, if I'm in R and I hit the run everything button,
Mm-hmm.
okay, so say I get stuck
Mhm.
up here, can I continue to go down? Or will
You
it
can.
It will be all wrong from there
You
on?
can if the next chunk doesn't depend on that one.
Okay.
So in the homework, sometimes in real life, sometimes we do one step and we need that one to run in order to do the next one. Sometimes they're like all distinct, so it depends. So there's not always one answer.
Okay.
So now in R, you don't want to do the run all necessarily on the homework. Well, some of the chunks I said include equals false because they're like example chunks, and so they won't run because they're like just a kind of example. So those example chunks don't run. Like I just wanted to type out the code with like variable 1 and variable 2 or continuous variable and categorical variable words in place of where you would put real variables just to show you how it would look.
Okay.
So if it's if it's that chunk, it shouldn't run, and so you can just skip it.
Okay. And then, so while I was out,
Uh-huh.
I did all my summaries.
Uh-huh.
But I didn't do them in R because
That's
I'm
okay.
really struggling to get them
That's
uploaded.
okay.
So can you show me how to upload my summaries again?
Yeah, I think that it's only set to do them as PDF.
Oh, just PDF.
So let me see if that's the case, and if that's the case, then I'll add, you did them in Word? Mm-hmm. So I'll add Word as a possibility. Because I can't remember.
But I really want to do it in R because I feel like it's like a fundamental skill.
I think you're fine without it.
For the summaries?
Mm-hmm.
All I know is that I can't hook this up to any other.
All right, and then what are your office hours tomorrow?
Oh, tomorrow.
And Thursday, right?
Let's see.
You should be able to have your admin add the RICOR printer in the sped department. Because if you're a student in our department, you should be able to print on our printer. So it's the big RICOR printer. And
Okay.
they just request that you try and print multiple pages on a sheet if you can and avoid filler. But you can do whatever.
Okay, so
For permission to add
for Tuesday,
special ed printer because you're a part of
Yeah, I know.
so you should be able to print, because like all the articles and stuff for reading, you should be able to print them off and done.
so that's noon.
I don't print any articles after I class, I'm just like one screen.
Yeah. Well, and that's fine if you prefer that, but
Well, I know,
sometimes for
I
me, I
don't
like
prefer
to.
that, but I also don't prefer walk all the way across campus to.
But if you have to come pick them up for general reading, so
Yeah.
when you're there, just print your stuff and then,
Yeah.
you know what I mean?
Um,
That's what I do. I would ask my admin for the RICOR printer. You don't need the LaserJet, because nobody reads that. But the brand new one they got is super nice. Doesn't use very much ink. You can print.
How do we know if it's something we should email you about or something we should go to office hours
What am I
about?
doing?
Thank you for staying late.
Sure. That is a good question. There's not an always answer because
See you tomorrow, Liz.
See ya.
So it's okay if I try. My classes are Monday, Wednesday. So
Uh-huh.
I don't have any class on campus Tuesday,
Tuesday, Thursday. Well, you can attend by Zoom. See, there's the Zoom link.
So do we just check in on the Zoom? Like
You
okay,
just
we're
click
waiting?
that link and should open it up.
Oh my gosh. Okay.
Now, if you log on and I'm not there yet, and then I log on, it won't connect us. So if you log on and I'm not on there yet, log off and try in a couple minutes because it seems like it should work because you click to go to that meeting and then I click start meeting, but it won't join you. I have to start it before you join it. So I try to remember to start it first, but I don't always, I get caught up doing something else. And, I'm going to stop the recording.